Okay, so good morning, everyone. Welcome to another Learning at Lambert Labs session. And today's presenter is Tom. So I'll hand over to Tom.
Okay, thank you, Aaron. So today I wanted to talk about WSGI and Gunicorn. So the structure of this talk will be in three parts. So I'll start off by saying what WSGI is, and then we'll look at two implementations. We'll look at Gunicorn, which is a WSGI server, and Django, which is a WSGI app. We'll see kind of what makes those WSGI implementations specifically. So in order to kind of explain what WSGI is, I think the simplest way is actually to show you a simple Python web application. So let's have a look here. Okay, so this is a web application written in Python, and it uses native packages. So it's using this HTTP package, which comes with Python. So there are no third-party things here at all. And we'll start off by looking at these three lines at the bottom. So what this is doing is it's creating an HTTP server using this server address here. So it's 127.0.0.1 at port 8000. And it's attaching to the server HTTP request handler defined up here. And once we create that server, we then serve forever. If we look closer at the request handler, this is inheriting from the simple HTTP request handler, which comes from Python. And that request handler has a method called doGet. And doGet basically is called whenever a GET request arrives at the server. So what I'm doing is I'm overriding that method, and I'm sending a 200 response. I'm then saying to the server, okay, I'm not going to put any more headers. So even though I haven't actually added any headers, I need to include this line to say I'm done adding headers. And finally, I include the response body, which is in this case, hi there. So let's see this in action. So I'm going to run python serve.py, which is the name of the file. And if I just open up the browser, yeah, so if I go to this address, I get the response hi there, and you can see it's logged here as a request. And I can do the same and so on. Okay, so that's a very, very simple web server. Now, I go back to my slides. So this is the same thing that you just saw. This is the bottom three lines. And if you kind of look at this code, you'll see this code is actually doing two things, really. And you can split the code in two parts. So you can say there's a kind of application part, which is this part here, which kind of tells you what's to do with requests. The rest of the code, on the other hand, it actually serves the application. And we have this kind of imaginary interface between these two parts. So this is a classic case of something called a separation of concerns in computing. We have this app, which is really doing two things at once. And when we see this kind of separation of concerns, it's quite often a good idea to split those out into two separate programs. And WSGI actually kind of gives us a standard way of doing that. So WSGI stands for the Web Server Gateway Interface, and it's a standard interface between servers and Python web applications. The interface is defined in PEP 3333. And what this all basically means is that servers and web applications are guaranteed to work together as long as you follow the specification here. So one person could write a server in isolation, another person can write an app application in isolation, and they will work together as long as you follow a certain set of rules. So in order to kind of, so yeah, I'm talking about this specification here. So what is that specification? So I'll show you I'll demonstrate by building a WSGI web application this time. And so what I'm going to do is I'm going to take this code here and I'm going to rewrite it as a WSGI web application. So it should be much smaller than this. So I'm only going to be handling kind of this part, just the bit that handles requests. So I'm going to stop this server down here. I'm going to create a new file. I'm going to call it WSGI serve. And so the WSGI web application is a function. I'm going to call it my web app. And it takes in two environment variables. Two arguments. So the first argument, environment, is basically the request. It's a Python dictionary which contains all the information about the incoming request. So it's very similar. If you've worked with Django, it's very similar to the request objects which you have in views. It contains everything about the request. And start response is a function itself which takes in two arguments. The first argument is the status code of the response, and the second argument is a list of headers. We're just going to keep that empty for now. And the response body is actually what the app returns. And the app returns, according to the specification, it should return a list of byte strings. We're just going to have one element in that list. And that element is going to be the response body. And there we have it. That's actually that's the simplest WSGI web application, which copies the behavior from this Python application. So this is just going to take in any GET request, or actually any request at all in this case, and it's going to just reply with a 200, no headers, and body will be hi there. Okay, so yes, that's just what we've gone through. So how do we actually run this now? Well, we need a WSGI server, and I'm going to use a third-party implementation called Gunicorn. And so I'll just demonstrate this. So we have this WSGI app. So in order to run it using the WSGI server, or using Gunicorn, I'm going to write in my terminal. I'm going to type in Gunicorn. I'm going to specify the address under which the server is. I'm going to set the log level to debug so you can see everything. And finally, we need to point Gunicorn to this WSGI app. And the way this is done is we take the name of the module. In this case, it's WSGI serve. We do a colon, and we type in the name of the app, which is in our case, my web app. Hopefully that works. Yep, it's booted. And so now if I go into my browser and click, and go to that address, you can see it's logged there. And by the way, this sig winch thing here, that's a signal that happens when I resize a window. So just ignore that completely. Okay, so I hope that kind of shows you. So what we've done, just to kind of recap, is we've taken this original web application written completely in Python, and we've actually just taken out the application bit. We've written that as a WSGI app, and we've used a WSGI server to run that completely and to kind of have the whole server running. Okay, so let's talk a bit more about what Gunicorn how it works. So Gunicorn is something known as a pre-fork worker. It uses the pre-fork worker model. So a worker means a separate instance of the web application, and pre-fork means that the workers are created prior to any requests being received. So in our case, the workers are created as soon as I boot Gunicorn. This is as opposed to workers starting up as a request comes in. The workers are managed by a master process, which does not interfere with the web application in any way. So the workers, the master process, all it does is it just kind of makes sure that there are workers running, and if a worker were to crash, then the master will try and create a new worker, basically. That's all the master process does. It doesn't know anything about the application. And finally, Gunicorn has different worker types. So the default one is called sync, which stands for synchronous. But there are other worker types available too. So if I go back to the console, you can see when I booted, it's saying it's using worker sync, and it's also using one worker. So this raises a bit of a question, I guess, because if we have one worker and it's a synchronous worker, so does that mean that our server can only handle one request at a time? Because if so, then that's that's not ideal, of course. So just to test that, what I'm going to do is I'm going to kind of add a sleep into my app, and this sleep is kind of resembles a blocking call. So in the real world, this might be like a call, a call somewhere to the internet, where it might be a DB operation or something basically which causes the web server to wait for another process to finish. That's kind of really definition of a blocking call. So this sleep, this kind of models that, so we can use that for our experiment. So just import time. Sorry, and also just going to add some print statements so you know what's going on. Okay, let me restart Gunicorn. There we go. So it's one worker, it's a sync worker. And so in my browser, I have two tabs. So if I just refresh the page once, you'll see it says waiting. And then after 3 seconds, it's done. Now, if I try and click, if I have two tabs, if I try and make a request quickly in succession, so as you can see, the requests are handled synchronously. So the first request has to be finished before the second request can start to be processed. So this is a bit of a worry. If one request takes a long time, that means that every other client of this server has to wait for that first client to finish. So how can we improve this? So there are a few ways. So one thing we can do is we can increase the number of workers to 2. So let's try that. So we're going to restart with Gunicorn, and we're going to add this flag, so workers 2. And it says it's booted with 2 workers. If I do this test now, then it's happening in parallel, as you can see. Both requests are started at the same time and then finish at the same time. So that's good, but the disadvantage of that is that, if you remember, one worker is one app instance. So if we have big apps, then that could take up a lot of resources. So this is a kind of last resort almost. Another way we can kind of increase the number of concurrent requests, we can increase the number of threads. We can keep one worker only, but we can increase the number of threads to 2. So let's do that. So I'm going to set the workers to 1, but threads to 2. And now if I do my experiment, you see the same thing. So yeah, the requests are happening, the responses are happening in parallel and handled. The requests are handled in parallel as well. So that's good, but the disadvantage of that is that the code must be thread safe. So it adds a kind of another restriction almost to our code. There is yet another way though. We can have one worker, we can have one thread, but we can change our worker type. So Gunicorn comes with many worker types. And most of these are called async types. Eventlet is one example of an async worker type. So if I just kind of demonstrate that first, so I'll keep the workers at 1 and threads at 1. I'll change the worker class to eventlet. You can see here it's saying using worker eventlets. And if I refresh these, then again, these are happening in parallel. So what actually is an eventlet? So basically, eventlet means that your worker is using green threads, and these are pseudo threads. Essentially, that's what the green bit means. They're pseudo threads, and they're very cheap to create, and they're also thread safe because they're not actual real threads. They're coroutines. But the big disadvantage with using things like eventlet and really other async workers is that you have to write your code in a certain way. In our case, we didn't have to change anything because our code is so simple. I mean, it's just, yeah, it's like the simplest WSGI app imaginable, really. But just to give an example, eventlet is, it's a fairly popular async worker type. The most popular one right now is actually something called G-event. Well, this is probably like the most used, the most maintained one, G-event. But if I wanted to demonstrate to G-event, then I would have to import the G-event's version of time. And I'd have to do that for loads of similar Python functions. So that kind of gives you an idea what you have to kind of sacrifice if you want to use async workers. So these kind of green threads, they're very good, but you only really use them if you're really sure you need them, basically. So yeah, so that kind of sums that section up. And of course, you have to keep in mind that increasing workers or threads only makes a real difference if there are available resources. So if the code contains blocking calls. If one request takes up 90% of, what should I say, if each request takes up 90% of CPU, for example, then adding workers or threads will not make much of a difference, unfortunately. But the kind of overall point of this is not so much to show you like request concurrency and show you what that is, but really just to kind of demonstrate that the fact that we can even begin applying such features 5 minutes after starting to build our web app is impressive, and the testaments to WSGI, because what the key thing that WSGI does is it allows us to split a full server in half, so that we have a kind of the actual server bit separate and the web app bit separate. And so we can create our web app in isolation, and we can pick and choose whatever server we want to serve that web app. In this case, we choose Gunicorn, and as you can see, it works quite well. Whereas if you wanted to do if we wanted to update our original app, then we would need to write our thread code, our worker code here ourselves. So yeah, and so just to kind of round off, in this presentation, I built kind of my own WSGI app. But in fact, all the popular Django web frameworks, they use WSGI. It's like Django, Flask, Bottle, they're WSGI web frameworks. And you can see that in Django, if you've worked on a Django project recently and you go into the kind of the core folder, you'll see this file called WSGI.py. And this file contains the WSGI application here. And so if you want to run the Django app using Gunicorn, this is the command you would use. It would be Gunicorn WSGI, the name of the module, and then application, name of the WSGI application. And that is in case how we deploy a lot of our Django applications. So yeah, I think that's come the end of the presentation. So does anyone have any questions?
I've got one, Tom. Thanks for the talk. Just thinking back to your code, I think that so in the WSGI serve file, your web app, you assume it takes two. That function definition has got two parameters: environ and start response.
Yep.
And you're using start response in line 8. Where would we be able to see a definition of start response? Like, is that somewhere defined in the Gunicorn application?
Yes, that's right. So these arguments are provided by the server. Yeah, so they come from the server. And the way this actually works is when I start Gunicorn, right at the end, of course, I specify the module and the name of this function here. And so in the Gunicorn source code, there's what Gunicorn basically does is it imports this, just like, you know, it kind of does from WSGI serve import to my web app. And so it's just a function available for Gunicorn, and then Gunicorn can pass in whatever it wants. And so the definition of start response, yeah, it's in Gunicorn. Yeah.
Yeah, and so crucially, it is written in Python because it's part.
Yes, it is. Yeah, it is. Yeah.
Yeah. Okay. Cool. Thanks.
Thanks, Tom. I got a question as well. Actually, like, what is included in that kind of first argument of my web app environment?
Well, I mean, I could share. Well, basically, it's a Python dictionary, and well, in fact, we got a few minutes. So I'll just print it. I think that's probably the simplest way. So yeah, so if I just oh, sorry. There we go. So if I do a request here, so yeah, it's a whole lot of stuff. Request method gets, go query string, user agent, connection, cookie. I mean, these come from the request headers. The name of the server, the name of server ports, also host, HTTP host. So yeah, pretty much what the Gunicorn does is it will take the incoming HTTP request and it'll generate a dictionary basically out of that request, and it'll add in maybe other values as well. So yeah, so that's why I say it's very similar to like the Django request or fast request object. Yeah, hopefully that kind of answers your question.
Yeah, definitely. And I could see actually, I think I saw query string as a key there, so it kind of it's passing the URL.
It is, yeah. I mean, yeah, it's yeah, there it is. Yeah,
yeah.
It's I mean, yeah. I mean, we can even. I mean, if I do a. I mean, that's updated the path. Yeah, path info ABC. For example. So yeah, the environment contains everything you need to actually figure out what the URL is, so you know which view to call in Django, for example. Yeah.
Nice.
So Tom, one more question for me. Unicorn be used to serve a web application written in another language?
Can Gunicorn be used?
Yeah. So if instead of your My Web App function application that you've got written on screen, that if that was written in, say, Node, you know, some JS, would Unicorn be able to handle that? Do you know?
I don't know for sure, but I highly doubt it, because I know, for example, that this environment variable, it needs to be a Python dictionary. It can't be anything else. And so that kind of implies that you need a Python. You need this written in Python. WSGI is pretty much a Python. It's PEP. It's a Python thing. So it only really works between two Python programs.
Okay, thanks.
I think no more questions. Thank you again, Tom, for the presentation.
Yeah, thanks.
Thanks, Tom.